Welcome to this comprehensive guide on implementing object pooling manually in Visual Studio and Unity 3D. Object pooling is a powerful software design pattern used to manage a collection of pre-initialized objects, ready for immediate use. Instead of constantly allocating and destroying objects, clients request an object from the pool, use it, and then return it. This pattern is primarily used for performance, significantly improving efficiency in certain circumstances. The core concepts include the object pool itself, which is the container, and the pooled object, which is the managed item. The client is the entity that requests and returns objects, completing the cycle of reuse. Object pooling offers several key benefits, starting with improved performance by reducing the overhead of object creation and destruction. It also leads to reduced memory allocation overhead, preventing memory fragmentation. Furthermore, object pooling minimizes garbage collection spikes, which helps maintain stable frame rates in applications. Resource management is enhanced as the pool controls the number of instances, limiting overall resource usage. Finally, object pools contribute to scalability, allowing the number of objects to be tuned based on application requirements. So, when should you use object pooling? It's ideal when object instantiation is expensive. It's also beneficial when objects are frequently created and destroyed, such as bullets in a shooting game. Other scenarios include particle systems, frequently spawning enemies, and UI elements like floating damage numbers. Now, let's dive into implementing object pooling manually in Visual Studio using C#. First, we'll create the pooled object class, which represents the type of object stored in our pool. This class will define the properties and behaviors of the objects we intend to reuse. Next, we create the object pool class, which is responsible for managing the collection of objects. This class typically includes a collection, like a list or queue, to store the objects. It also needs methods to create new objects, retrieve objects from the pool, and return objects to the pool. Let's implement the getObject method. This method retrieves an object from the pool. If the pool is empty, it creates a new object, ensuring we always have an instance available. Now, we implement the returnObject method. This method adds an object back to the pool after it has been used. It's crucial to reset the object to a default state before returning it, preparing it for its next use. Optionally, you can use a factory pattern to encapsulate the object creation logic, making your code cleaner. For multi-threaded environments, remember to consider thread safety by using appropriate locking mechanisms. Here's a complete C# code example for our generic object pool class. It includes the objects list, max size constructor, and the get and return methods. We also have our simple myObject class with an ID property. And here's an example class demonstrating how to use the object pool to get and return myObject instances. Now, let's transition to implementing object pooling within the Unity 3D engine. First, create a script for the pooled object, defining its behavior. This script will typically handle activation, deactivation, and any reset logic for the object. Next, create a script for the object pool itself, which will manage the collection of these pooled objects. This manager script will need a collection to store the objects, similar to our C# example. Crucially, it will also need a reference to the prefab of the object to be pooled. Implement methods to create new objects, retrieve them from the pool, and return them. At the start of the scene, instantiate a set number of objects and add them to the pool. Remember to deactivate these initial objects to hide them until they are needed. When an object is needed, retrieve it from the pool and activate it. If the pool is empty, instantiate a new object and add it to the pool for future use. When the object is no longer needed, deactivate it and return it to the pool. For Unity 2021 LTS and later, Unity provides a built-in object pool class in the Unity engine, pool namespace. This class offers an efficient and convenient way to implement object pooling directly within Unity projects. Here are some helpful tips for beginners to make your object pooling journey smoother. Start with a simple implementation and gradually add complexity as your understanding grows. Use descriptive names for variables and methods to significantly improve code readability. Always add comments to explain the purpose of different code sections, especially for complex logic. Thoroughly test your object pool to ensure it is working correctly under various conditions. Consider using Unity's built-in Object Pool class for easier implementation in Unity projects, especially for Unity 2021 LTS and later. Remember to reset objects to a default state when returning them to the pool. This is a common pitfall. Finally, profile your code to identify performance bottlenecks and optimize accordingly. While powerful, object pooling has considerations. It can consume memory even when objects are not in use. Implementing object pooling can also add complexity to your codebase. It's not always necessary and may not provide significant performance improvement in all cases. Carefully evaluate if object pooling truly benefits your specific application before implementing. You've now learned the fundamentals of manual object pooling in Visual Studio and Unity 3D. This technique is invaluable for optimizing performance in games and other resource-intensive applications. Experiment with these concepts in your own projects to see the performance benefits firsthand. Thank you for watching, and happy coding!